Hi, good morning, welcome students. In today's class, we are going to see about the derivations of Poissons and Laplace equations. I am going to teach it very simple, okay? So first of all, we are going to derive this derivation from Gauss law. Gauss law we know. What is Gauss law? From Gauss law, we know what psi is equal to Q, okay? Psi is equal to Q. This is Gauss law. So what is psi? Psi is nothing but electric flux. Psi is nothing but electric flux. So what is flux density? D is electric flux density. So what is the relation between these two? Electric flux density D is equal to electric flux per surface. That is d psi divided by ds is nothing but electric flux density. D psi divided by ds. If I am in need of d psi, what I will do is I just do cross multiplication. So d psi is equal to d cross ds. So d dot ds, okay? So if I want to find psi, means I want to integrate on both sides. Here it is surface, so surface integration on both sides. It is a closed surface, so psi is equal to what? D dot ds, surface integration. So you can also put double integration, otherwise you can put single integration, and in the subscript you want to put s, okay? So psi is equal to integral of d dot ds. It is in vector form also you can represent, okay? This is first equation and this is second equation. So I can also write Q in another form. In what form I can write? So we all know there are two types of charge densities. I have already taught you in my previous lectures. If you go through, means you can able to find it. Let me give you a small recap about that. There are three types of charge densities. They are line charge density rho L, surface charge density rho S, volume charge density rho V. Here I am going to take volume charge density. So see here, flux density means flux per surface. So here for charge distribution there are three types of charge density. So I am going to take volume charge density. Rho V is equal to charge per volume. So dq divided by dv. If I am in need of dq, I want to cross multiply. So dq is equal to rho V dv. If I am in need of q, means I want to do volume integration on both sides. So differentiation integration get cancelled. You can find the value of q is equal to triple integral of rho v dv, because volume integration, instead of writing v in the subscript I am writing triple integration. That's it, okay? So q is equal to what? Triple integration of rho v dv. This is my third equation, and now I am going to substitute these two equations in the first equation. So what is the value of psi is equal to q is equal to, yes, double integral of d dot ds is equal to triple integral of rho v dv. This is my, yes, fourth equation. And we all know from divergence theorem, what we know? From divergence theorem, we can convert, yes, surface integration into volume integration by taking divergence. So here I am going to consider this d dot ds. So how can I convert from divergence theorem? Surface integration of a vector, closed surface integration of a vector is equal to divergence of the same vector, okay? Divergence of volume integration of the same vector. Volume integration. So here I am putting dv, okay? So see here I am converting surface integration into volume integration. So here again I am going to equate. This is my fifth equation. I am going to substitute instead of d dot ds. See here d dot ds. Here also it's closed integration. I am going to substitute this particular volume integration here, okay? So equating this one and this one, equating fourth equation is equal to fifth equation. So what I am getting is triple integral of d dot del dot d dv is equal to triple integral of rho v dv. This is my sixth equation. So you just cancel on the both sides. You are having volume integration. So you just no need to consider the volume integration. In the inner part you are going to consider. So del dot d is equal to what? Rho v. Del dot d is equal to rho v. Clear? Del dot d is equal to rho v. and instead of writing D, what is the relation between D and E vector? D is equal to epsilon naught E vector for free space. So I am going to substitute this 8th equation in 8th equation and 7th equation instead of D. So del dot instead of D, here we are writing epsilon naught E vector is equal to rho V. So this is my 9th equation. So what I can write, instead of writing E, I can represent E as gradient, potential gradient. Okay, so E vector is nothing, we know E vector is equal to negative symbol of gradient of the potential. This is my 10th equation. I am going to substitute this E vector. Instead of writing E vector, I am going to represent this del V here. So what I will get is del dot epsilon naught minus del V is equal to rho V. Here epsilon naught constant, so you just take it out. Okay, so epsilon naught del dot del minus, bring it in front. So del dot del is nothing but what? Del squared is. So del squared V is equal to rho V. So again del squared V is equal to rho V divided by epsilon naught. Bring this minus here. This is our Poisson's equation. This is our Poisson's equation. So if the conductor we are assuming is charge free, means if the medium we are assuming is charge free, means no charge. So what is the value of volume charge density? Yes, rho V is equal to 0. So if we putting rho V is equal to 0, del squared V is equal to 0. This is our Laplace equation. That's all. So thank you.